Welcome to my channel. I'm Zhang Xu. Let's look at the problem 67 in chapter 30. Chapter 30 is about inductance, electromagnetic oscillations, and AC circuits. So there we can see we need to determine a formula for the average power consumed in the LRC circuit in terms of LRC, omega, and V0. So keyword average power just consumed in LRC circuit, right? So we can write down the equation about average power P in the LRC circuit. Look like this one. You can get it directly from the textbook equation 30. Now we can see in this equation we have root mean squared current, root mean squared voltage, and cosine phi. This phi is the shift angle, right? Shift angle. Now phase angle. Now we can see we can write down the root mean square current as the voltage of the root mean square voltage divided by impedance. And the cosine phi can be written as the resistance divided by impedance Z. And then how do you know Z? Z impedance is determined by R resistance, XL inductance, XC capacitance. By there, it says the term is in omega. So it looks like you need to keep going, right? We look at the inductance XC as 2 pi FL. There, this is F is a frequency. Omega is called angular frequency. As we know, angular frequency omega equal to 2 pi F. So now you can write the XL inductance as omega L. Similarly, you can get capacitance XC as 1 over 2 pi FC, right? So 2 pi F as omega, so it's 1 over omega C. Next one, you can see there we have the root mean squared voltage, right? But it tells you need to use V0. So the root mean squared voltage equal to V0 divided by square 2. Now we come back. The average power P in the RLC circuit, we can see we input this one, root mean squared current as V, root mean squared divided by Z, right? And cosine phi as R over Z. Now we simplify it. It looks like this one. Now we replace root mean square voltage as V0 divided by square 2. So then it looks like this one. In this equation, you can see we can replace the Z as the equation, right? Squared R squared plus XL minus XC squared. So this one. Now replace Z, we can see we need to put the XL and XC as the equation about omega. So we replace the XL as omega L, replace the XC as 1 over omega C. Now we are done. It looks like this one. The second part, what is the frequency? What frequency is a power maximum? So this power is maximum is called resonant frequency, right? As resonant frequency is a function you can directly find in the equation 1 over 2 pi LC. The next one, find an approximate formula for the width of resonance peak in average power. So what is difference in the two frequencies where P has half of its maximum value? It looks like a little bit difficult, but I think we can work it out together. So first question, it tells you ask the difference in two frequencies where P has half its maximum value. So first part, let's find its maximum value. Okay. Now its maximum value we can see is the frequency is at its resonant frequency. So the power become maximum, right? So in this case, it looks like we can input the F0 in the average power equation to get the maximum power, right? So maximum power, we can see, as we talk about, omega is the 2 pi F, right? Now this F becomes F0, resonant frequency. So we can replace omega as 2 pi F0, there omega as 2 pi F0, right? So it looks like this one. Now we keep going. As we note in this equation, we can see f naught as 1 over 2 pi squared LC. So we input it inside. It looks like this one, right? And there you can see 2 pi cancels. 2 pi cancels. And this one becomes squared L over C. This one also becomes squared L over C. So this term becomes 0. And then we can simplify it, looks like this one, right? So that means the maximum average power is in this term. This is a small term, very simple. Now we come back. It asks us what is the power equals half of its maximum. So that means the average power equals half of its maximum. And the maximum, we just calculate this one, right? So now we can come back. So input the equation for average power there and the maximum average power there. So it looks like this one, right? Now look like this one, you can see if this need to equals, so that means this term should equal to 2r squared, right? And then we simplify it, we get the equation look like this one. Now we solve this equation about omega. We get the omega has 2 values, 2 frequencies, right? So now ask you, what is the difference in 2 frequencies? So now what is difference in 2 frequencies? So delta omega naught uses the positive value minus the negative value. We get answer there. Thank you.